Hello trigonometry students, my name is Jami Emigh and this video continues our discussion on chapter 4. We're going to start with this example where we're asked to determine an equation for this graph right here. This is the opposite of what we did in the last video. In the last videos we were given the equation and we were asked to graph it. Here we're given the graph and asked to determine one appropriate equation to represent that graph. Okay. So when you look at the graph, we don't see a line, so don't think y equals mx plus b. There's no parabola here. It looks like a trigonometric function. So you might ask yourself, well, which trig function does it look like? Hopefully you get a little mental sketch of sine and cosine. And if we're choosing between these two, which one do you think this graph looks more like? If you said cosine, good start. That's what I'm going to go with as well. Now we can see that the parent function of cosine has been transformed. A few things have happened. Let's figure out what. Starting with the letter A for amplitude. All right, parent function of cosine bounces between +1 and -1. And we can see that our graph goes up to 2 and down to -2. So the amp has increased. Additionally, it's not starting at its max. Ours is reflected in the x-axis, so starting at its minimum right here. So those two pieces of information would lead us to A being -2. Okay, what else? Okay, so we are building our equation as we go. So far we have cosine, and we have A equals -2, which would go in front of the trig function. All right, after A, we check out B. We know that B affects the period of the graph. So we look at the current period. Well, the parent function has period 2 pi. Our graph has period of 4 pi. So what we're going to do is set 4 pi equal to the parent function's period, which is 2 pi, divided by B. Now we write that equation, and what it does is gives us only one unknown, so we can use that to solve for B. All right, so 4 pi is equal to 2 pi over B, multiply both sides by B, and then divide both sides by 4 pi, and we get B equals 1/2. Okay, so tacking that onto our equation, that would go after cosine. And looking at our graph, there are no other transformations that we know of yet, so we are going to just put in terms of x, and we have written one possible equation for this graph. Okay, on the next slide we're going to learn a different transformation, and that's where the graph could be just pushed to the left or to the right. I'm bringing it up now because there are other possible answers or equations that would accurately represent this graph. For example, somebody might have gone, I think this looks more like sine, and that would be a reasonable thing to discuss, because if we start right here, it increases, decreases, and then we know that if it continued on, it would complete one cycle that looks like sine. It just, however, appears that it's been pushed over to the side. So instead of sine, parent function, which passes through the origin, it's like it's been pushed this direction pi many radians, and it starts here. So let me elaborate. A horizontal translation is called a phase shift. That's where the graph of the function y equals f of x minus d is translated horizontally compared to its parent function. The expression x minus d is what we call the argument, okay? So the argument is going to tell us if a graph is shifted to the left or to the right. If our argument is x plus some value, we're going to shift left. And if our argument is x minus some value, we're going to shift right. Let me show you an example, not using a trig function. Let's look at an example. Here we have a function given to us. It's this one in blue. And if this function's argument is currently x, if it changes to x minus 4, so this is the new argument, you can see that the resulting graph has been shifted to the right. So it's like taking this blue one and just pushing it to the right 4 units. And we get all that information from the argument, x minus 4. Here, our argument has changed from x into x plus 3. We know if our argument is x plus a value, that means it's shifted left, and we can see that on the graph here as well. It's shifted to the left 3 units. So that's another type of translation we're going to add to our already transformations we've discussed, amplitude and period. Note here that d is not positive 3 though, because look here in our general form, y equals f of x minus d. The minus is from the general form, which means, let me rewrite this for you. In the notation given to us in general form, that would be minus, because that's required, x minus, and the only way for that to equate to this argument of x plus 3 is if we're subtracting a negative, because subtraction of a negative results in the positive that you see here. So if you're asked, does it shift to the left or the right? Well, when you see a plus sign, it does shift to the left. And if you're asked what d is equal to, it would be the opposite sign of what you see. So for this particular one, d would equal negative 3. Here's what I wrote out, just in a nicer typed out form for you. And d shows itself when we write it in that form. All right, let's do the same thing over here. Note here that d is going to be equal to the opposite sign. So instead of minus 4, d is positive 4. Similarly, standard form would be x minus 4. So to make that equivalent to what we have here, d would have to be, whoops, positive 4. Translation. Didn't add that right there. There's a d equals 4. All right. Let's use this example to see if we followed along with what a horizontal or phase shift is. We're being asked to graph y equals sine of x minus pi over 3. So parent function, we've got sine. Going through the alphabet, a is the implied 1, so the amplitude's not going to change from the parent function. B is the coefficient in front of x, or after sine here. Again, that's 1, so the period is not going to change from the parent function. But the next letter we've discussed is d, and we can see in the argument here that d is pi over 3. So we're going to take the parent function sine and we're going to shift it to the right. Pi over 3 radians. All right, let's see what that looks like right now a little more formally. I'm going to erase my pen so we can see it here. Okay, going through the alphabet, we have a equals, and it's 1, leaving our amplitude, same as the parent function. B equals 1, leaving our period, the same as the parent function, which is 2 pi. And D is pi over 3, which means we're going to shift that function to the right. Okay, so just one transformation takes place. So we start with the parent function, y equals sine of x, and then we transform in the order that we're learning these. You want to go A, B, then D. Well, A is no transformation, B is no transformation, so really this one is just D, but it would look like this here. Parent function is this dashed red graph, and the function that we're being asked to graph, y equals sine of x minus pi over 3, is here in blue. And you can see it is just the parent function gone through one transformation, which is being shifted to the right, pi over 3 radians. Okay, if we want to find more of our key points that we use when graphing, we would take our pi over 3, and we know that it would take 2 pi mini radians to complete this cycle of sine. So you can find this value right here by just taking your original 2 pi but adding that translation to it of pi over 3. That'll get you to the ending point. So then you would have the start, you would have the end, and then remember we just look for 3 points in between. Halfway between pi over 3 and 7 pi over 3 is 4 pi over 3. Then we go halfway between those two, which is 5 pi over 6. And then halfway between the last two, which is at 11 pi over 6. And there we have our 5 points that help guide us through sketching the sine curve. All right, let's try another one. Here we have an example where we're asked to graph y equals 3 cosine of x plus pi over 4 over 1 period. Okay, so let's talk this out going in alphabetical order. A first. A is 3. It's positive, so our amplitude is 3, no reflection. B is 1. It's right here. So no transformation to the period of the parent function of cosine, so it remains 2 pi. We skip C, okay? We go A, B, now D. D, we can see from the argument, is negative pi over 4, and that means we're going to shift our function to the left, pi over 4 radians. And now we're going to start with the parent function, which is y equals cosine of x, and we're going to make our transformations in this order. A, B, followed by D. Okay. First one, parent function, we can see, let me add that parent function to this visual. Parent function y equals cosine of x would start up here at 1. It would end at 2 pi. So talking about fourths, that would be 8 pi over 4. So it would start here, it would end here. Halfway between, it would be at its minimum, which for the parent function is -1. Halfway between these two, it would be crossing the x-axis. So for the parent function, that's here. And halfway between these two, it would be crossing the x-axis again, parent function right here. Okay, so this is the graph of the parent function. I'll make it dashed, but a little like bigger dashes. All right, so that right there is one cycle of y equals cosine x. Now transforming that in order, A, we amp it up. So instead of bouncing between +1 and -1, we're going between +3 and -3. B affects the period, which in our case, no effect on the period. And D says to shift this parent function to the left. So it's going to start at negative pi over 4 radians. That brings us to this solid blue line, blue curve, which represents 1 period of y equals 3 cosine of x plus pi over 4. All right, let's try another graphing example. Here we're asked to graph y equals -2 cosine of 3x plus pi. Okay, before we dive into this one, I want you to notice that it's not in standard form. This 3 in front of the x is what tells me that. If the parentheses were not here and the plus pi was not there, cosine of 3x, that would be fine. But here we have cosine of 3x plus pi. So we need to factor this 3 out to get this in standard form. Factored form would look like this right here. Taking out a 3 gives us the result of 3 times x, and factor means divide. So dividing this by 3 leaves us with pi over 3. So this is the form that we want to look at when trying to graph this function through all its transformations. Okay, starting with lowercase a, A is -2, so that tells us two things. We're going to be amping up from 1 to 2, and the negative tells us that we're going to reflect this graph in the x-axis. B is right here. It is 3. Remember, that is not the period, it affects the period. So we take the current period, which is 2 pi, we divide that by 3 to get the new period. D, in our argument, D is equal to -pi/3, which means that we're going to shift this function pi/3 radians to the left before we start it. Okay, so we're going to graph the parent function, y equals cosine x, and then we're going to transform in that order, a, b, d. All right, I've added an x and y axis to our piece of graph paper right here. And let's start with the parent function, y equals cosine of x. Here it would be at its maximum, 2 pi radians later, back again. Halfway between the two it'd be at its minimum. Halfway between these two, it's crossing the x-axis. And halfway between these two, it's crossing the x-axis. Instead of actually connecting the dots, I'm going to leave it like this for now because there are a lot of transformations and this can start to get quite cluttered. So what I've done so far is just the parent function, y equals cosine of x. That's what those 5 dots, if we connected them with a smooth curve, would represent. Let me change colors. And in red, I'm going to do the first transformation, changing the amplitude to 2. So I'm going to take my 5 points. If we amp up to 2, the maximum is now here, minimum down to -2, and the ones on the x-axis remain where they're at. Okay, let me change colors again. And in yellow, I want to highlight what the reflection in the x-axis of those 5 points would be. All right, don't look at the blue ones anymore, just looking at the red ones, one at a time. This one here, reflected in the x-axis, is equidistant on the other side. Second one stays where it's at, 'cause it's on the x-axis. This one's mirror image here. This one stays where it's at. And this last one, reflection, is equidistant on the other side of the x-axis. All right, this yellow is kind of light, and we've done a couple transformations so far, so I'll go ahead and connect these with a smooth curve just so you can see what our graph looks like so far. Okay, next we have b equals 3, so that means that our period is going to change from this original 2 pi to 2 pi over b, or 2 pi over 3, if you will. So instead of it taking 2 pi radians for this cycle of cosine to complete, it has to be done in a third that amount, in a third of that many radians. So 2 pi over 3 is right here. So just working with the yellow, try to ignore the red and the blue. It would start here and has to end here. Halfway between, we're at a max. Halfway between these two, we're on the x-axis. And halfway between these two, we're on the x-axis. So this is where we're at now after B. Okay, D. D is negative pi over 3. So we need to shift our 5 green points to the left pi over 3 radians. So let me color code this. So we just did this part in green. Let's get another color. All right, let's do this part now in this lighter blue color. So moving the green one, pi over 3 units to the left, we are here, 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 whoops, here, and here. So now we're starting at negative pi over 3, which I didn't line it up very well with my axis. So here's our graph as of now. You can see if we had connected the dots through every transformation, it would be quite cluttered. So here we are now. So try to ignore the red, the blue, the yellow, and the green. This is where we're at. And, oh, that was our last transformation. So a graph of that, you can actually connect that with a smooth curve. That would just be one cycle. Wow, that's terrible. Let's see what the graphic looks like. It's a lot better than mine. Here we go. So this is the one that we just developed right here. This one period of -2 cosine of 3x plus pi. This one. And then just showing that the graph extends in both directions. We go here and here as well. All right, I'm going to erase all of my pen so that you can see what that result looks like without it. There. All right. A vertical translation is where the graph of the function of the form y equals c plus f of x is translated vertically compared to its original function y equals f of x. So you might have been wondering, we've addressed A and B and D, but we skipped C. Well, we're going to address it right now. If we see C, that is just a constant added to our function, then it is going to translate or slide our function up or down. So we'll translate C many units up if C is positive, and we're going to translate that same many units down if C is negative, but we'd have to look at the absolute value if it were negative, and in that case we go the same distance, but we translate down instead of up. Let's see a sketch. Here we have a function, y equals f of x, and the argument isn't affected this time. That stays the same. If the argument is affected, you're talking about d. Here, we just have the addition of a positive 3, so this graph is translated or slid up 3 units. And here, we've got the same graph, same function, same argument, but we have the addition of a -5, so it is translated down 5 units. All right, so that's one example of what a vertical translation looks like. Let's try one using a trig function. Here we're asked to graph y equals 3 minus 2 cosine of 3 pi over 2 periods. So we have a lot going on. This is the first time we're seeing that we have a c, so I just added the standard form here. So we can remember c is equal to 3. Here is our a, it's -2 there. B is the 3, and we do not have d in this particular question, so I'll just write d equals 0. All right, let's go through these one at a time. A is -2, that means our amplitude is the absolute value of that, which is 2. The negative means that our graph is going to be reflected in the x-axis. B is 3, so our period is going to change from the original 2 pi to 2 pi over 3. D is 0 in our function, so we're not going to shift to the left or to the right. And now C equals 3, so we are going to have a vertical translation up 3 units. All right, we're going to start with the parent function, y equals cosine of x, and we're going to transform in that order, a, b, d, c. Okay, I've added an x and y axis and some values to help guide us. Now let's start with a for amplitude. A is -2. Oh, I forgot to graph the parent function. Let me add that first. Y equals cosine of x. So we are here, 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 halfway between, pi over 2. This is not very good to scale because I had to squish the 2 pi. Okay, that'll work. All right, now we're going to amp that up to 2. So max. Minimum is down at 2 now, so 1 out here. These ones stay where they're at. And I'm going to reflect. Let me change colors for that. I think we did yellow last time for the reflection. So that brings us to, whoops, minimum to start, stays on the axis, reflecting. Now we're at a max, stays on the axis, and at a min. Okay, I'll connect those. Whoa. Okay. And next is B. Let's switch back to, I think we used green for this last time. All right, we're going to change the period to 2 pi over 3. So we're going to squish this down again. It's going to start here. It's going to end here this time. Halfway between, we're at our max. Halfway between these two, we're on the x-axis. And halfway between these two, we're on the x-axis. Okay, D would say shift it to the left or the right, but we do have no horizontal shift. C says to shift this 3 units up. So let me switch colors. All right, so I'm gonna take each of the green and shift them up 3 units. So that would be 1, 2, 3. So here we are. This one here, 1, 2, 3. Third one, up 1, 2, 3. Fourth green dot, up 3. And finally the 5th green dot, up 3. Okay, anything else? No, that's it. So this right here is 1 period of, my goodness, of 3 minus 2 cosine of 3x. Second period we can do on this side. I'm just going to sketch it. I'll show you the graphic. That looks a lot better than mine. But what we have right there is 2 periods of y equals 3 minus 2 cosine of 3x. Let me erase all my pen and show you the image. Oh, actually, let's put the image up first. Okay, we're pretty close. Pretty close. Our first one looks good. Sketch was quite a bit off for that second period, but we can see here. And now I'll erase all of my pen. And there we have a nice image of 2 periods of y equals 3 minus 2 cosine of 3x. All right, last example, and then we'll pause and do some homework. Graph y equals -1 plus 2 sine of 4x plus pi over 2 intervals. Before you start, notice that this 4 needs to be factored out to put this in the standard form. 4 times the argument x plus pi over 4. So I want you to pause the video, use this form, go through your alphabet, A, B, D, and C, and try to graph this function. Welcome back. Let's see how you did. If you came up with A is 2, B is 4, D is -pi over 4, and C is -1, good job. If you noted that your amplitude is 2 at that point, your period changes to pi over 2, your horizontal shift is to the left, and your vertical shift is down, then you got those all right as well. Start with graphing the parent function, y equals sine of x, and then transform those in order, A, B, D, C. Your resulting graph should look like this here. All right. Let's take a break and do some homework. Chapter 4. This video should help you out with numbers 19 through 34. My name is Jamie Emigh. Thank you for being here. I will see you next time.